Alright guys, trick number 1. So we will using a program that is called Oak for this trick. Please focus here on the screen. As you can see, I have seen my own face very small in this setup because looking at my face is not very important. Look at the command line, please. So Oak was developed by 3 friends in the Bell Laboratories and in California almost half a century ago. That's amazing, right? That even now it remains so powerful and then so relevant for doing bioinformatics. Okay, then if you just type Oak, then you will find a description of the software and the options that you can use in it. So let's list our content. And there is 4 files here that we will be using for this tutorial. And let's first see the first 5 lines of the file taxa, comma separated values. And what we have here is a text file that is in a comma separated format, which by the way I don't like because I find it hard to read by the human eye. We will change that later, but for now let's assume that this is the format of the file we will be working with because it's pretty common in bioinformatics. So essentially what we have in the first column is an ID, and those are bacterial taxa like actinobacteria, for example. And then we have a series of numbers, and those numbers correspond to the abundance of those bacteria in this series of samples that you can see here. All right. There's many things we can do with a simple file like that. So in the first exercise, as I told you, we will be using Oak to sum up all the values or the abundance of bacteria in the first sample, which occupies the second column, right? Okay, we will call Oak, and then we will pass an argument that is F to indicate that this file is separated. The values in this file are separated by a comma, and then we will write a single quotation mark to indicate that a specific Oak commands are coming here. So essentially we will write 2 little blocks of commands here, or of code, and we will create a variable that is called sum, that recursively will hold the sum of each of the rows. And then it's up to this point, and then we will make that variable equal to itself plus whatever number comes when reading all the rows in the second column. Remember that the first column is occupied by the ID. That's why we are using here the second column. And once that has finished, and then we will ask Oak to print that sum, and we will be performing all that in the taxa file, right? And then you can see that we have effectively calculated the sum of all the values in the second column. Of course, we could do that for any column we want, right? For example, let's do it for column 10. Awesome, right?